Hey everybody. So we're gonna continue with the substitution rule that we've been looking at, which I suppose I'll maybe rewrite here. This is the problem I'm going to start with doing. We're expanding because in the last video we didn't do anything with a definite integral. We had the following. We said if u equals g of x, then we get that if we have an integral of this form, that this is equal to this integral, right? So this tells us how to find antiderivatives of our functions, okay? So we're going to use that idea now with a definite integral, and there's actually two ways that we can approach this, okay? So in general, if I have a definite integral, what do I need? I need, we actually have the endpoints. I need f of 5 minus f of 2, where f prime of x is equal to natural log of x over x, right? That's what I need. I need an antiderivative of this function, and I can evaluate it at the endpoints. That's just our definition of the definite integral. So one way we could approach this problem is to use the substitution rule to get an antiderivative and then come back to this. In other words, let's start by doing this problem. And then, oops, that's not a u, that's an x. And then we'll come back to the original problem. So let's forget about the top part. I'm going to use our substitution idea. This one's not as obvious, and it's perfectly fine. One thing you'll note as you move forward through these videos, we're just going to keep cataloging ways in which we can compute integrals, more and more methods. We've got the substitution method, and we're going to get a whole bunch more. Sometimes it's not obvious what to use. It's perfectly reasonable to just take a guess and see what happens. Okay, so let's try this. It might not be as, or I can maybe make it more obvious if we rewrite this problem like this. All right, same thing. I'm just rewriting this using rules of fractions. And then you might notice that 1 over x is the derivative of natural log of x, which leads us to try this substitution. All right, which now is pretty clear that it's going to work. Right, so this will be in replacing natural log of x, I've got u, and replacing 1 over x, I've got du. Okay, now this I can take its antiderivative using our original set of antiderivatives, using what I like to call the reverse power rule. I know that this has to go up by 1. Its exponent is 1, but then I'm going to need a constant here to deal with when that 2 comes down. And now I can go back on my substitution and replace u with the natural log of x plus c, right? And it's always good to double check that the thing you got actually works. So let's just go ahead and take the derivative of 1/2 natural log of x squared plus c. We're going to have to take, it's a chain rule, so the 2 comes down. I've got that 1/2 out front times the natural log of x times the derivative of the inside, which is 1 over x, which of course is the original function. Oh, and the derivative of the constant is 0. Okay, so this is indeed an antiderivative of the original function. Well, that's exactly what we said we needed. We have the integral from 2 to 5 of natural log over x dx. We know to compute it, we find an antiderivative. I now have one. I can ignore the constant since I'm actually evaluating this, and we just need to evaluate it from 2 to 5. We know it's an antiderivative because of what we just did up here. We found it using the substitution rule, and then of course we double checked that it was the antiderivative. And so this becomes 1/2 the natural log of 5 squared minus 1/2 the natural log of 2 squared. Or maybe I'll write it as 1/2 natural log of 5 squared minus natural log of 2 squared. Okay, and that's good enough. Those are numbers, those we would compute with a calculator if we wanted to get the final answer there. So this is one way to do it. You have a definite integral, use substitution to get the antiderivative, then use that antiderivative and the fundamental theorem of calculus to compute the integral. However, there's another way we can do this, so I'll demonstrate that now. And I don't prefer either way. It just depends on, it doesn't really matter which one that we use. And so it's a matter of personal choice. I probably go back and forth between the two of them, depending on the problem. So let's go back. Oops, I wrote this wrong over here. Pardon me, let me just correct this work. This looks really ugly. That will be x dx, pardon me. Okay, so we've got the natural log of x dx. Instead of pausing our definite integral, going to an indefinite integral, we can stay in the realm of the definite integral and still use substitution. And the way we'll do it is, I'll still make that same substitution. du is going to be 1/x dx. And I'll get the integral of u du. However, I have to pay attention to my bounds, right? This is as x goes from 2 to 5, but now I'm not dealing with x, I'm dealing with u. So I'm going to come over off to the side and say when x equals 2, u equals the natural log of 2. So that bottom bound becomes the natural log of 2. And when x equals 5, u equals the natural log of 5. Right? And this is a perfectly reasonable thing to write. Those are two numbers. This becomes the antiderivative of u is 1/2 u squared. And I'm evaluating this from the natural log of 2 to the natural log of 5, which is equal to 1/2 natural log of 5 squared minus the natural log of 2 squared, which is exactly what we got up above. Okay? It's really just whether or not we're switching back to the formula with x in it at the end or earlier. But this is perfectly reasonable to do. People prefer either way depending on their personal preference. I don't think there's a huge difference. Let me just write this new rule once for clarity. We would say if G is continuous on AB, the closed interval AB, and F is continuous on the range of U equals G of X, then a little bit, the integral from A to B of F prime G of X G prime of X dx is equal to G of A G of B F of U du. Okay, which is just what we did up here. We took, instead of finding an antiderivative in terms of x, we changed our integral into an integral of u and changed the bounds to the corresponding u values given the substitution, right? G of A was like our natural log of 2, G of B was like our natural log of 5. Okay, that's it for this one. I just wanted to point out how to do these definite integrals. Again, one last time, I will say either method is acceptable. Finding an antiderivative and then applying the fundamental theorem of calculus, or using this rule when you make this, the substitution straight away. The nice thing about the first method is there's just kind of less going on at once, and that can be a bit easier, especially in the beginning. But maybe as you, with practice, you might start to shift over towards this second method. But I'll leave that up to you as long as you're checking your work Either one should work just fine. Okay, thanks everybody. See you next time.